What is the Hubble constant? The Hubble constant is a value which represents the rate at which the universe is expanding. Why should we care about the Hubble constant? If we know the Hubble constant, we will know the age and rate of expansion of the universe. And this will give us insights as to the nature of the universe, what it is made out of, and in what percentage, and how the laws of physics work in this universe. What is the problem with the Hubble constant? The Hubble constant assumes that the universe is expanding uniformly everywhere. That is why it is called a constant. However, our observations show that objects that are far away from us, the furthest objects we can detect, are not moving away at the same rate as other objects closer to us. Therefore, the Hubble constant is not a constant. In the year 2001, a scientist named Wendy Friedman measured the Hubble constant and found a value of 72 kilometers per second per megaparsec. However, based on the physics that scientists believe has driven the evolution of the universe, the Hubble constant should be around 68 kilometers per second per megaparsec. Why the discrepancy? There is something missing in our understanding of the universe. Friedman's equation was derived from Einstein's general relativity. And that equation states that a dense universe expands more quickly. And so, the rate of the universe's expansion was faster when all of the particles of the universe were packed close together at the Big Bang. There are 3 ways currently to measure the Hubble constant. The first is to use astronomical measurements of nearby objects to see how fast they are moving. This is what the 2001 measurement did, using supernovae, type 1a supernovae in galaxies, to measure how far away and how fast those galaxies were moving away from us. Another way to measure is to measure the gravitational waves from colliding black holes or neutron stars. A third way to measure is by measuring the leftover light from the Big Bang, also known as the cosmic background radiation. all of these numbers give different answers to the question. What is the Hubble constant? So why are there these discrepancies? There are several possible reasons. One could be that the methods of measurement or calculation of those measurements are flawed. However, with the precise nature and techniques being used to measure, this seems rather unlikely. Another explanation is that there is more dark energy in the early universe than our current theory allows for. Another explanation is that there exists something called dark radiation, which essentially would be a new class of subatomic particle that travels near the speed of light and increases the rate of the expansion of the universe. One more theory that could explain the discrepancy is that dark matter might interact with the universe in ways we currently do not understand. So what are scientists doing to find out more and resolve these discrepancies? They are doing three things that come to mind. One, they are building new telescopes with which to measure the cosmic background radiation more precisely and refine their measurements. Another technique uses gravitational lensing in order to measure the distance of very far away objects more closely. And the third is to wait for more collisions of black holes or neutron stars to get more measurements from gravitational waves. But until then, we are still left with this conundrum. The numbers just don't add up.